Hello, I'm Donald O'Hare. This is my lab report for Lab 2 in Principles of Physics. So in this lab, we record and track the system of a crumpled piece of paper over time using Tracker. It was thrown underhand, and we used the Tracker data to calculate the starting velocity and position to put into our GlowScript models. We assumed the ball weighed 5 grams or 0.005 kilograms and had a drag coefficient of 0.001. And we modeled the X and Y position of this ball over time in real time and in GlowScript. So the arc of the ball was over 0.633 seconds before it struck the ground, and gravity and drag acted on the ball during this flight. Starting position was 0 meters in X and 0.17 meters in Y. Any slight movement in the Z-axis was ignored, and it is important to note that the camera was not framed perfectly. So in the GlowScript models, we use Newton's second law to update the velocity in the while loop with the net force divided by mass times delta t added to our initial velocity, and that was iterated upon many times. F net was equal to F of gravity plus F of drag, but in one of the models we set the drag constant equal to 0, and as you see, the force of drag equals negative drag constant times velocity squared times magnitude of velocity. So that would effectively eliminate the drag force in that, but in both gravities acting on it at the constant rate of 9.8 meters per second times mass. And the position was also updated by the same logic, with the initial position having the velocity times delta t added to it. Starting velocity given by Tracker was 1.2, 2.40 meters per second, and the aforementioned starting position. In the GlowScript shell, these were iterated upon every 0.01 seconds over 0.633 seconds, so about 633 times. And these equations were used to plot the location of the paper ball in the X and Y axis over this time. As mentioned, we had one with and without air resistance, and all of them made a roughly parabolic path, and at no point was terminal velocity reached, but an experiment to figure out what it was could be dropping the paper ball from a higher point so that there was more time for gravity to act on it and for it to reach that terminal velocity. And these are our graphs in GlowScript and Tracker, and this is the Tracker with drag. Did the position graphs over that amount of time it took to hit the ground. We could see where the actual position ends. On the y-axis is where the ground was, and then we can see the other two with and without drag. So quick what if it was thrown straight up? It would take longer to hit the ground because all of the velocity, we're assuming the same with the thrown velocity, would be in the y direction, which would counteract the gravity force stronger because there'd be less of it spent, so to speak, in the x direction. So it would reach a higher point before being pushed down by gravity, so it would spend more time in the air, and air resistance is negligible for the sake of this comparison. So the most noticeable difference is that the GlowScript graphs have the ball hitting the ground far before it actually does, and crossing into the negative y when modeled for that same amount of time. And the drag graph has a more noticeable dampening effect on the motion than without drag, but both of them still fall short, even without drag. And they weren't able to very accurately model the real life ball's movement. So there are a few reasons for this difference between prediction and reality. And so as mentioned before, human error in the tracking and the filming plays a large role. And also the drag of the ball isn't constant, and it's constantly changing since it's such an irregular object. But the main thing is that any minor inaccuracy in the initial velocity or position is going to be iterated upon so many times in the GlowScript scripts that it will end up being totally different because there's so many calculations on this one given value that it can't be the same as real life because there's so many more changing effects in real life as compared to in the GlowScript model. So this is slightly disappointing that we didn't get the level of accuracy that we wanted, but it does show us that an important detail that any inaccuracy at all when tracking motion and porting that over to GlowScript can lead to larger inaccuracies, and that it is difficult to model air resistance due to the ever-changing nature of that. And I believe that we could amend this with better filming and more like a greater FPS, better setup. And it does still show us the importance of technology and that it still plays a role, but you have to use it correctly or you're going to have inaccuracies.